Good morning, guys. I hope you're doing well. So, Happy New Year, and looking forward to seeing you guys in person. So, we'll talk about solving Unit 7. We'll get started right away, solving trig equations with identities. And I'm just going to remind you of some of the things we talked about before you left, and then see how we can use those identities or those ideas to solve equations. The very first one I hope you remember is that cosecant or cosec, written as CSC, is the same thing as 1 over sine theta. Right? We did this last semester. Secant is the same thing as 1 over cosine theta, or also known as sec. And cotangent is the same thing as 1 over tan theta, or if you simplify it, because tan is sine over cos, so you have 1 over sine over cosine theta. So this ends up being just cosine theta over sine theta, right? Tan theta is sine over cosine. You guys remember this? And cotangent theta is the same thing as this. So that's that. I hope you remember this identity that sine squared theta plus cosine squared theta is equal to 1. It comes from this right angled triangle. Sorry about that. From this right angled triangle in which you have this side being 1 unit and this side being this being your angle. I drew that triangle wrong. It's easier if it faces this way. Right, this is your angle theta, this is your x distance, and that's your y distance, and this is 1. So if you use Pythagoras, you can see that x squared plus y squared is equal to 1. But if you also use trigonometry, if you use SOHCAHTOA, you can see that sine theta is equal to y divided by 1, and cosine theta is equal to x divided by 1. I'm just reviewing this, but I'm sure you remember it. I'm reviewing it because you guys have just been eating food and probably forgot about this, but that's why I'm reviewing it. So if you use Pythagoras and you get x squared plus y squared is equal to 1 from this same triangle, then you can substitute for x and y, because x is cosine and y is sine is equal to 1. So yeah, this is the very first identity. I'm sure you wrote it down on your cheat cards or something like that. If you didn't, please write it down. So these are the things I've been talking about. Cosecant is 1 over sine, secant is 1 over cos, cotangent is 1 over tan, or cos over sine. Sine squared plus cosine squared is equal to 1. Now we can do some interesting algebra with this. If I divide this whole expression by sine squared theta, divide by sine squared theta, divided by sine squared theta, I will get sine over sine is 1, which is what you see. What's happening? Yeah, sine over sine is 1, which is this one that you see here. Cosine over sine is cotangent, which is what you see here. And 1 over sine squared will become cosecant squared theta. So this is another identity that I hope you added to your cheat sheet. Alright, and then if I divide all through by cosine, if I divide by cosine theta here, divide by cosine squared theta, divided by cosine squared theta, I end up having 1, because sine over sine is 1, that is this one here. Cosine over cosine, sorry, forgive me. Sine over cosine is tangent, right? Cosine over cosine is 1, and 1 over cosine is secant squared. So these are the 3 big identities at the moment that we're going to have to use a lot to simplify and solve trig equations. More identities are coming, so please make sure you have space on your cheat sheet before you write them. So let's look at some examples. Oh, before we go there, I hope you remember the odd identities are all the ones that have either sine or, tan. All the ones that have a relationship with sine are odd, and all the ones that have a relationship with cosine are even. Meaning that if the negative is inside on the input value, it doesn't change the output value for even identities. But if the negative is on the input value, it changes the output value for the odd identities. Okay, so examples: find the exact value if any of each of these composite functions. Tan theta divided by secant theta. I'm just going to break this down. This is the same thing as tan theta divided by secant theta. And then I'll break it down into its constituents. Tan is the same as sine over cosine, and secant is the same as 1 over cosine. So if you guys do KFC, or if you do the simplifying here, sine theta over cosine theta, this will become times or multiply by cosine theta over 1, and that cancels and you just end up with sine theta. So we're going to be doing this a lot, breaking down expressions like this and simplifying them into expressions like this. And I know you might be wondering when or how or where is this going to help me in my life. The truth is, practically, unless you're going to take higher math courses, or if you're going to get into programming, or that kind of thing, that's where they will help you because you will need them. But if you're not, then the biggest advantage you're getting out of this, and I say this a lot, is training your brain to find and recognize patterns and get one solution from another solution, or write one thing so many different ways, or say one thing so many different ways. So you can thank the universe for training your brain using these math expressions. Find the exact value of each composite function. Okay, let's see. We know this is an odd function because the negative is on the input value. So let's just keep that in mind. I know it will become negative sine x. I'm going to skip to this one. This is all multiplication. So multiply by, I'm going to skip to this one. Cosecant is also an odd function, and it's the same as 1 over negative sine x. And it's still being multiplied by cosine x. But I know this is an even function, so this negative does not affect the output value. What I have here is a negative sign divided by a negative sign. They will cancel out, and my answer just ends up being cosine x. So this whole thing, which you looked at and got scared, simply comes down to cosine x. So yeah, simplify the first trigonometric expression by writing the simplified form in terms of the second expression. So I want us to write this whole thing in terms of cosine. Easy. I mean, don't get scared. Break it down, right? So break it down. We have cosine of x divided by 1 plus sine of x, plus I can break down tan into sine over cosine. Now, when I break down tan into sine over cosine, all of a sudden I have a fraction, and I can add this fraction. I don't know how you guys add fractions, but there's this simple trick of multiply those, and then multiply these. Or if you're using LCM, it's the same idea. So at the top I'll have cosine squared x, because this cosine multiplies that cosine to get cosine squared x, plus sine of x, open brackets, 1 plus sine x, because this multiplies that one down there, and the denominator becomes 1 plus sine x, open brackets, cosine x. So what I have at the top is cosine squared x plus, when I distribute this, sine x times 1 is sine x plus sine x. Oh, sorry. Sine x plus sine squared x divided by 1 plus sine x times cosine x. Now, if you look at the numerator of this, I have cosine squared x plus sine squared x, right? And if I take you back a few steps, many steps, you remember that sine squared x plus cosine squared x is the same thing as 1, uno. So instead of dealing with this sine squared x plus cosine squared x, I'm just going to replace the whole thing with 1, right? That is what we're trying to do today. So I'm going to replace it with 1. No, I picked the wrong thing. Never mind. I put these brackets around the wrong thing. Okay, so this sine squared x, this cosine squared x, and that sine squared x, those two are going to combine to give me 1, right? And then I'll have 1 plus sine x divided by 1 plus sine x, close brackets, cosine x. So I hope you can see that 1 plus sine x at the top and 1 plus sine x at the bottom can cross out because they are the same brackets. And my expression simplifies to 1 out of cosine x, which is what they asked me. They asked me to write it in terms of the second expression, which is cosine x. So that's just 1 out of cosine x, which you can write as secant x if you want, and you're done. All right, let's look at another one. This thing again, trying to write it in terms of cosecant. Again, LCM. So when I use the LCM, I'm going to add these fractions. This is the simplest trick in the book. Cross multiply and then multiply the denominators. So I'll have 1 times 1 plus cosine x, which is just 1 plus cosine x, minus cosine x into 1 minus cosine x, divided by 1 minus cosine x, cross brackets 1 plus cosine x. Alright, so let me simplify the top. The top is 1 plus cosine x minus cosine x plus cosine times cosine is cosine squared x. All divided by, when you look at the bottom, I have 1 minus cosine and 1 plus cosine. I hope you remember your algebra from 8th grade. If you have a minus b and a plus b, this is known as the difference of squares, because when you expand that expression, you end up with a squared minus b squared. It's known as the difference of squares. So that's what I'm going to use. I know that at the bottom, I'm going to end up with 1 minus cosine squared x. So then I start simplifying. The top becomes, I see 1 positive cosine, negative cosine, these two cross out. So I'm left with 1 plus cosine squared x divided by 1 minus cosine squared x. Now I hope you remember the very first identity is sine squared x plus cosine squared x is equal to 1, right? So if I want to substitute for cosine squared x, which I have, or if I try to make sine squared x the subject, I hope you can see that I'll be subtracting cosine squared x from both sides. So the sine squared x will be 1 minus cosine squared x. So that's what I'm going to put in the denominator. But as for the numerator, from this same expression, if I want to make cosine squared x the subject, it will just be cosine squared x the subject will just be 1 minus sine squared x. Okay, so let's try to substitute that and see. I end up with wait, did I make a mistake? 1 plus cosine minus, just give me a second. Okay, I didn't make a mistake. I was just getting confused because it's a new year. So what we have is 1 plus cosine squared x at the top, and then at the bottom I have seen that 1 minus cosine squared x is the same thing as sine squared x, so I'll just put sine squared x. So I've simplified it as much as I can, but they still told me to write it in terms of cosecant. So I'm going to break down this fraction. This fraction is the same thing as 1 over sine squared x plus cosine squared x divided by sine squared x. So 1 over sine squared x is cosecant squared x, but cosine squared x divided by sine squared x is cotangent squared x. So now I need to go and check, is there an expression that relates cotangent with what I want to get? So I'll go back here and see cotangent and cosecant. If I have cotangent plus 1 is equal to cosecant, so that means that cotangent alone will be equal to cosecant minus 1. So cotangent squared theta will be equal to cosecant squared theta minus 1. So that's what I'm going to put here. Instead of cotangent, I will put cosecant squared x minus 1. So my final answer is going to end up being 2 cosecant squared x minus 1. So again, the purpose of this majorly is to help your brain to identify these patterns, these relationships, and use them mostly. Okay, verify the identity. When they say verify the identity, they're trying to get you to simplify the left hand side of the expression to show that it's equal to the right hand side of the expression. So again, we're going to do a lot of breaking down. So tan x at the top is the same as sine x over cosine x. Cotangent is the same as cosine x over sine x. And at the bottom, secant times cosecant is the same thing as 1 over cosine times 1 over sine. I'm going to simplify these big fractions. Simplifying these big fractions, I'll start like this. Oldest trick in the book. Sine times sine is sine squared x. Cosine times cosine is cosine squared x, divided by cosine times sine is cosine times sine. Cosine x, sine x. And then I'm dividing that whole thing by 1 over sine x cosine x. I hope you can agree that since I'm dividing by 1 over cosine x sine x, that's going to become the same thing as multiplying by cosine x sine x, because I want to cancel out this and this, right? That whole thing crosses out. This thing crosses out with this thing. And when that crosses out, I'm only left with sine squared x plus cosine squared x, which I have seen so many times that that is 1. So I have shown that the right hand side of the expression is equal to the left hand side of the expression. So I've verified that identity. And then last one, I want to show that this is equal to that. I'm just going to expand it. I hope you remember that when you expand this common product, you get a squared plus 2ab plus b squared. So that's what I'm going to do. If this sine is my a and this cosine is my b, then sine x plus cosine x squared is going to become sine squared x plus 2 sine x cosine x plus cosine squared x. And I'm going to combine them. I see a sine squared and I see a cosine squared, and they're being added. And I know that when you add those two according to the first identity, you get 1. So that's just 1 plus 2 sine x cosine x. And you have showed or verified that identity as well. So yeah, this is your homework. Have fun. If you have any questions, send me an email or a comment. Bye.